Konnichiwa, watashi no namae wa Marius desu. And that's it, Ori, with my little Japanese. So don't be worried for the English-speaking audience, you don't have to plug in something. And also, don't be worried for the Japanese-speaking audience to have to bother with my little Japanese. My presentation is about crafting collaborative apps with RAM. And to get started with that, I want to figure out first, what is a collaborative app at all? So a collaborative app is something we understand usually as an app which can be used by multiple people at the same time to work on the same task. The slide here doesn't show all the logos of very popular RAM apps, but it shows instead very popular collaborative apps you might have used in your work or even now on your trip if you're coming from abroad. Or just used in your free time to organize yourself and your daily life, like the to-do list apps we have on here. And so now where that's cleared up, let's go to the Realm mobile database, which was the first product we launched. But before I go to a short explanation, what is that, I want to make a quick poll with the audience. So who has heard about Realm before? Can you point up and raise your hands? Wow. Nice to see so many hands by now. Now, a little harder, who has played around with Realm? That's still super impressive to see. And the hardest level, who has shipped an app with Realm to the App Store? Nice. Glad to see so many hands. Let's build some common ground for those who didn't know or haven't played around with Realm yet. Just very quickly go through that. Let me answer what is Realm and what it is not by emphasizing one very important point, as that could be a very common misunderstanding when you see other technologies which look from the use very similar. Realm is not an object relational mapper. It is the database itself. In fact, it is an embedded, NoSQL, object-oriented database. Embedded means for us, it was optimized for the hardware constraints for mobile. Unlike SQLite, which was originally built for guided missile destroyers to guide rockets. We have built Realm from the very beginning with mobile in mind and just embedded devices. NoSQL. So that means indifferentiation from many new databases, especially on the server side popping up. It's not a database which has not a fixed schema and is constraining the type of data you can put into it. Realm has a fixed schema to allow this performance and be so fast as it is. And to go back to our buzzwords, the last point, object-oriented. How does that look like for Realm? We can see here a schema definition, and it's only done here, only done in the code, not done in some editor you have to mess around with. And when you're working on a bigger team, you would need to merge conflicts of a weird XML file you don't really understand. You can just define your class in code as you do any other class. You have to inherit from a framework-given special superclass, which is just called object in the case of Realm Swift, and then can define your properties. There are some rules around that, but for atomic properties, it's relatively straightforward. You can define them as dynamic properties so that they become available to the Objective-C runtime. And you can also define links even with a built-in collection type, which we just call list, which allows here a person to have children within your schema. And as you can see from that, there is no need to introduce any foreign keys. There is no object relational mismatch. You can describe your model just like how it is. And now with that common ground for Realm, the mobile database, let's move on to Realm, the mobile platform, which we just introduced end of last year. With that, we extend the mobile database to the server side. This gives new deployment options. So far, the mobile database has only been on iOS and Android in the respective native host languages, which are Java for Android and Objective-C and Swift for iOS development. But we also support cross-platform approach with technologies like React Native and Xamarin. On the server side, you can deploy the database yourself on existing infrastructure or in the cloud of your own choice. And you can integrate with the event handling with the Node.js framework, which allows you to access the objects and interact with events and make writes even. So what do you can achieve with that? What does this platform allow you to cover, and how would it work? So in the most simple scenario, you could allow your users to have an easy way to synchronize continuously and back up their devices to your server. So if they lose their devices or switch to the new iPhone generation, they can relatively trivial just sign up or log into the app again and get the old data. That can be extended, and there it gets already tricky with existing technologies if you want to allow cross-device synchronization. What does it mean? How could that look like? That could look like I sit at home on my iPad on a couch and set up my grocery list for tomorrow when I'm going to the grocery store and write down what I want to shop there. And my grocery list will be automatically synced into the cloud on my server so that when I'm there tomorrow and put the stuff into my basket, I just can cross off what I put in there, and we'll see later on that I got all my stuff or what I missed to get. And with that, we can go to a more complicated use case. Then we would basically have the same with like two devices, but would allow multiple people to interact with the same data simultaneously. And there is the use case all this talk is about, real-time collaboration. And now let's jump to a very concrete example. For our launch, we built an example application which allows you to draw together on a virtual canvas. This app comes actually quite handy for me trying to learn Japanese a bit because I can use it together with my sensei, my teacher, to practice the stroke order, how kanjis, radicals, and vocabularies look like. So let's jump into a very concrete example now. We could use that app and have FaceTime at the same time, use the picture-in-picture mode, and he could instruct me which kanjis or what I should draw, or just show me drawings of stuff he wants to show me. So he is asking me, do you want to learn something great today? And I will obviously answer with imadesho. Let's do it. So here's what I'm saying. You will learn a new vocabulary word today. For that, he's introducing me to the kanji for clear up. In fact, I can learn this based on radicals I actually already know. So starting out with drawing the kanji for day sun on the middle left. And as soon as I do that, all my brushes will be created as objects in the Canvas application and will be synced up to the server and made available there. In the next step, they will be automatically downloaded as well to my sensei's iPad, and so they can be shown there. He can give me some feedback to that. I'm doing great, for example. I hope so. And give me some further instructions about more radicals I need to draw, and probably tell me at some point that I need to watch my stroke order because this part is super complicated for me. So once that's done, and he can draw on his own also stuff to show me the rest and integrate that into a larger context, as he is announcing now. And all his change will be synchronized in the same way. At the same time, I can still do my changes, and they will be also synchronized over. And in the case they would be conflicting, the Realm mobile platform would take care of resolving those conflicts and integrating everything into one consistent transaction history, which gives you consistent data across the devices. So my chains are getting synced over, but now he could even lose his connection. But because Realm is built on, or the Realm mobile platform is built on the Realm mobile database, which supports persistency, it supports offline first, can be offline with our app. And it's not a big deal for us. In fact, we don't even need to take care of this whole scenario within our example app in a bigger way. So my teacher can just keep drawing the hiragana, which need to be attached here, and I can keep drawing. My chains will be still synced up to the server. His chain will be just stay local, and once he's back online, he will get my new chains I did in the meantime, and his chains will be synchronized over. And in the end, everything is great, and we figure out that this means literally great. Subarashi. And if you step back to our use cases, we can learn now that if we would not only use a single realm, as we did in this example, which is synchronized to the server, but instead multiple realms, which are synchronized separately with individual permissions, and some of them available to just myself, others available shared, and also together with others, we can effectively ban JSON from our apps, and so ban also the object relational mismatch we have to deal with, which is good because dealing with JSON, especially from a type-safe language like Swift, gets incredibly tricky to do it right. Just look at the sheer number of frameworks in Swift to manage that. Do you really want to reinvent the wheel over and over again? You don't need to spend your precious time anymore in writing code to map JSON back and forth. That reduces even the effort across multiple platforms, because you would need to solve it on every single platform if you are targeting iOS and Android. How is that possible on the server side? There are the built-in notifications, which also affects the client side. So built-in notifications, what has Realm to offer around that? The most fine-grained way to have notifications are notifications on individual properties. These are available via KVO. We integrate there very closely with the Objective-C runtime, which allows you to get changes whenever one particular property of an object changes, and trigger data chains from there in a very reactive manner. You can also do that a little bit more coarse just on objects. And going even further, we also allow fine-grained updates on collections, which allows you to tie that directly to your table views and collection views, and allows you to show nice animations when objects are locally added or even from other devices interacting, because you know what in your tables which data change. Going even further, you can do and trigger behavior in a global way if you set up notifications on the whole file. And with the Realm mobile platform now, we will learn about notifications you can trigger on all realms which are synchronized to the server. So how does that work, and how fits that together for our larger topic to replace our backends? If we would have an app which allows us to use coupons. We could create there in a ROM which is synchronized to the server for a particular user a coupon object where we set a coupon code to the given code the user has entered or he has scanned the QR code, wherever it's coming from. And this object will be synchronized up to the server. And up there, it will trigger a notification via the global event listener, which is part of the event handling framework we offered it. And there, you can trigger your validation code, which even allows you to make directly modifications to this object. So if you figure out that this code is valid for the purpose the user is using it for, then you can just set the is valid property of the coupon object to true, and this change will be synced back. The server-side write will be synced back to the client and made available there. And when you have set up, say, a listener on the individual property, on this is valid property, you can show in your UI that this object was validated now and the coupon is valid and the user can continue with his interaction with your app. So far, so nice. But if you think a bit bit further, when we have multiple ROMs involved, how does that all work? There's this big elephant in the room. How do we manage access to ROMs? Maybe you would think with a REST API, but didn't I just say before that this wouldn't be necessary anymore to have to deal with JSON? No, we use ROMs for that as well. We fully commit on our own approach here. And to make this possible, we have some special ROMs I want to present to you. So one ROM you shouldn't and would not directly interact with is the admin ROM, which is global to the whole server, but we internally use the synchronization engine for building the server itself as well. So that is the single source of truth for all permissions and even ROM files and users in the server. And beyond that, you have user-specific ROMs. Here on the slide, you will see their paths. They are written in a Unix style, like the home directory is written with this tilde. And there is the management ROM and the permission ROM. The management ROM is responsible for making modifications to permissions. You can create their permission change objects, permission offer, and permission offer response objects. We will learn about the former in the next step. And the permission ROM allows to mirror permissions affecting the particular user this path is for. When you would expand it, say this tilde would be replaced by user ID A. That would be the concrete permission ROM for this user. And you would see in that ROM all permissions which are affecting this user, which are all permissions he has granted to others and permissions which were granted to him by others to their files. If we put this now all together, we can see how you can make permission change. So in a first step, we would communicate with permission change a user ID from one user to the other user, effectively making the permission change. This could happen over existing channels like Line, Facebook Messenger, Snapchat, you call it, whatever you. So this user ID could be then encoded, say, in an uplink, which could be extracted and then used to set up the permission change object, which encodes the user ID and which path we want to set rights for on the server. This is then added to the management ROM and will be processed as soon as it's synced up to the server by the event handling framework. This, if done right, will trigger a change to the admin ROM, which stores, as we have learned, all the permissions. And this change internally of the ROM mobile platform will cause that this permission will be reflected within the permission ROM of the user we have received the user ID of. And if there are notification settings are up for this permission realm, you can directly interact with that and react to the new permissions which were granted. And that's already with my talk. So if you have any questions right now, feel free to ask them later after we finish up, and I thank you for your attention. Or otherwise, feel free to grab me or Katsumi or Tim Oliver, or if you know him as Tom Oliver, around the conference. And if you want to learn even more than that, there will be a workshop about Realm on Saturday. And you're welcome to join. Katsumi will be there as well, so no English required. And beyond that, I want to also make a little plug for our Realm World Tour, which is already sold out for Tokyo, but feel free to join the waitlist. And we also have another event in Osaka. And finally, arigato gozaimashita. I want to thank you for your attention.
お話ありがとうございました。今後このレールムのモバイルプラットフォームをその PHP などからなんか操作するような機能を追加するとかいう予定はありますか
？We have plans for supporting other mobile platforms, other server-side languages as well. And we have a repo on GitHub where we collect issues around that. And feel free to post any desires, any wishes around that there, so that we can make plans around that. Very concrete plans around PHP, I'm not aware of it so far. Unfortunately, but we have definitely plans for more server-side languages, which we want to support.
Thank you, Marius. Thank you.
Thank you for having me.